Welcome to your personalized deep dive, into cybersecurity. We're looking at new research papers from the Archive preprint server, all published on January 28th, 2025.
It's like a sneak peek into what's next in cybersecurity. We'll break down all the complex trends and, new technologies.
Yeah, today we're going to, tackle this question. How is the world of cybersecurity changing with AI and blockchain getting more popular?
That's the big question. We'll look at how these two big things are coming together and sometimes even clashing to shape the future of cybersecurity.
Okay, let's jump right in with this paper. Fiberpool leveraging multiple blockchains for decentralized pooled mining. They're proposing a new way to make mining cryptocurrency more secure and better.
Think of it as, a network of blockchains all working together to check transactions and keep the network safe. That's what Fiberpool is all about. It's trying to fix the problems with the way pooled mining works now, which often has problems with scaling up security and costs.
So it's not just using one blockchain, but many that are connected. That sounds pretty complicated. What does it actually mean for people who use or invest in cryptocurrency?
Well, think about it this way. Fiberpool wants to make mining cryptocurrency easier for everyone and harder to attack. The more decentralized and strong the mining is, the more secure and stable the whole cryptocurrency world becomes, which helps everyone involved in crypto.
Right, that makes sense. It seems like people are always trying to make blockchain technology better and more secure. This reminds me of another paper, a proof-producing compiler for blockchain applications. This one's all about those decentralized applications, or DApp apps.
Yeah, and dApps could totally change all kinds of industries, but keeping them safe is really important. Imagine a financial dApp handling, millions of dollars. If there's even one little security flaw, it could be disastrous.
This paper talks about using these formal verification tools to prove with math that the code for these dApps is correct. That sounds really complicated. How does all this math actually benefit the people using these dApps?
It brings a level of certainty that's never been seen in normal software. By proving the code is correct with math, we can get rid of a whole bunch of vulnerabilities and make dApps that are way more secure and dependable from the start.
It's like having a digital contract that can't be broken. The implications for how we build dApps in the future are huge. This could create a new era of trust and transparency in the decentralized world.
Absolutely. As we move towards a future where blockchain is a bigger part of everything, making sure those dApps are secure and reliable is going to be really, really important.
Okay, let's switch gears now and talk about AI and how it's impacting cybersecurity. It's a bit of a double-edged sword, isn't it?
Yeah, AI is definitely a powerful tool that can be used by both the good guys and the bad guys. All this new research we're seeing shows just how fast AI is changing the world of cybersecurity.
This one paper, Cryptanalysis via Machine Learning-Based Information Theoretic Metrics, really got my attention. It's about using machine learning to figure out how strong encryption algorithms are.
It's kind of like stress testing a vault, Researchers are using AI to find weak points in encryption, trying to find those vulnerabilities before the hackers do.
They talk about things like mutual information, neural estimation, and binary cross-entropy classification. That all sounds pretty complex. Can you break down how these things help us understand if our digital stuff is secure?
They give us a way to measure how much information might be leaking from an encryption algorithm. This helps us figure out how well it can hold up against, really sophisticated attacks and see where it needs to be improved. Like having a digital stethoscope, listening for those little signs of weakness in our encryption.
That's a good way to put it. It makes you wonder, though, if AI can be used to find weak spots in encryption, could it also be used to make even stronger encryption methods?
That's exactly what some researchers are working on right now. The same AI tools used to analyze how good existing algorithms are can also be used to come up with new, stronger encryption methods that can withstand even the most sophisticated attacks. It's an ongoing back and forth between those trying to break the code and those trying to protect it, and AI is right in the middle of it all.
Another really interesting use of AI is for spotting fraud in real time. The paper Advanced Real-Time Fraud Detection using RAG-based LLMs goes into that.
This one looks at how these large language models, or LLMs, can be powered by this thing called retrieval augmented generation technology. They can actually analyze phone calls to spot potential scams while they're happening. Imagine an AI system that listens in and warns you if it thinks someone is trying to scam you.
It's like having a digital bodyguard watching out for you.
Yeah.
How does this actually work, though? Does it listen to everything we say?
It's not really about listening to every single word, but more about finding those key phrases, the way someone's talking, and the patterns you see in conversations that are typical of scam calls. The LLM can basically turn those calls into text and analyze them in real time, flagging anything that seems fishy.
This RAG technology sounds really powerful. Does it need to be retrained all the time to keep up with all the new scams people come up with?
What's really cool about RAG is that it can keep learning and updating its knowledge base without needing a full retraining of the model, so it can adapt to new threats and scams as they pop up, getting better at its job over time.
That's a big deal for protecting people from scams. It's good to see AI being used to make us more secure in this increasingly digital world. But like we said before, AI can be a tool for the attackers too.
Let's look at two more papers that show the two sides of AI and cybersecurity. One is a two-stage CAE-based federated learning framework for efficient jamming detection in 5G networks. This one talks about how AI can be used to find and stop jamming attacks in 5G networks.
Right, those jamming attacks can really mess things up, especially for important infrastructure. This research is using AI to pinpoint those jamming signals and help protect everything that's connected in our world.
Exactly. Now think about the other side of the coin with this paper, intelligent code embedding framework for high-precision ransomware detection via multimodal execution path analysis. This one shows how AI can be used to make ransomware even more dangerous.
It's a scary reminder that AI can be used for good or bad. Understanding the potential threats from AI is just as important as exploring how it can help protect us.
Definitely. As we move deeper into this AI-driven world, cybersecurity professionals and researchers need to stay one step ahead, figuring out how AI will be used by both the good guys and the bad guys.
Okay, let's shift gears a bit and talk about the human element of cybersecurity. People are often called the weakest link, and they're frequently targeted by social engineering and all sorts of manipulation.
The paper, I Know What You Did Last Summer, identifying VR user activity through VR network traffic, shows this vulnerability in a really surprising way. Researchers found that they can figure out what someone is doing in virtual reality just by looking at their network traffic.
That's kind of creepy. Imagine someone knowing exactly what you're doing in a virtual world. It brings up some serious privacy questions. How's that even possible?
Even in these virtual places, we leave behind these little digital footprints. By looking at the patterns in network traffic, researchers can see which VR apps someone's using and even what they're doing in those apps.
The paper says that less than 10 minutes of traffic is all it takes to figure out these activities with really high accuracy. What does that mean for the future of privacy and all this virtual and augmented reality stuff?
As VR and AR get more popular, protecting people's privacy in those spaces is going to be crucial. We need to come up with better privacy-enhancing technologies and set some clear rules for how data can be collected and used in these new environments.
Another paper that caught my eye is PromptShield, deployable detection for prompt injection attacks. This one's focused on the security of large language models like the one we're using right now.
Right, LLMs can do amazing things, but they're not immune to attacks. Prompt injection is a technique where someone sneaks in specially designed prompts to trick the LLM into doing what they want.
So you're saying someone could theoretically inject a prompt that would make this LLM create like harmful or misleading content.
Exactly. This research shows how important it is to develop good defenses against those prompt injection attacks. The paper introduces PromptShield, which is a new tool designed to spot and stop those attacks, basically protecting the integrity and reliability of LLM technology.
It's like having a security guard for our AI, making sure no one tricks it into doing something bad.
Yeah.
This is super important as LLMs become more and more a part of our everyday lives.
Okay, so let's move on to something else that's really important in cybersecurity. Auditing and trust. This area is becoming more and more important as we see all these new AI models being developed and used.
Yeah, for sure. Accountability and transparency are key when it comes to making sure AI is developed responsibly. We need ways to verify that these AI systems are actually doing what they're supposed to and that they're not being used for harmful purposes.
And that's where this paper, A General Framework for Data Use Auditing of ML Models, comes in. It's a really interesting approach. They're talking about data use auditing, which is basically a way to check if your data was used to train an AI model, even if you don't know anything about the model itself.
That sounds like a powerful tool for protecting data privacy and holding AI developers accountable. Imagine being able to trace back where an AI model came from and making sure your data wasn't used without your permission.
Exactly. The framework uses techniques like black box membership inference and sequential hypothesis testing to do this. Think of it like detective work for data usage. It lets you see if your data was part of the training set for a model, even if you can't look inside the model itself.
That's impressive. It seems like we're moving towards a future where data usage can be tracked and audited, which will make AI development much more transparent and accountable.
Another important part of AI auditing is verifying who owns open source AI models. This is becoming more and more critical as these models become more widely available. The paper Print towards false claim resistant model ownership verification via targeted fingerprint is all about this challenge.
Open source models are really valuable for the AI community, but it's important to have clear ownership to prevent things like unauthorized use, plagiarism, and potential misuse.
Right, and that's where FET Print comes in. It introduces this technique for embedding what they call targeted fingerprints into AI models. These fingerprints act like unique IDs that can be used to prove who created the model, preventing false ownership claims, and protecting the intellectual property of developers.
This technique seems especially important as more and more people are sharing and collaborating on open source AI models. It's like having a digital watermark for AI, making sure the creators get credit and preventing unauthorized use.
Absolutely. Now, let's not forget about the importance of real-world data in cybersecurity research. The paper Real Cats, a practical training ground for emerging research on cryptocurrency cybercrime detection, really highlights this by introducing a new data set for researchers to use.
Cybercrime involving cryptocurrencies is a growing problem, and having access to real-world data is essential for developing effective ways to detect and prevent it. What makes this Real Cats dataset so valuable?
Real Cats gives researchers this rich and diverse collection of cryptocurrency transactions, both legitimate and criminal. This means they can develop and test their algorithms on a realistic data set, which will lead to better and more accurate cybercrime detection tools.
It sounds like a great resource for anyone working to make the cryptocurrency ecosystem more secure. This kind of data sharing and collaboration is so important for staying ahead of the constantly evolving tactics used by cybercriminals.
Okay, so let's move on to some unconventional attack vectors that are really pushing the boundaries of cybersecurity. These are attacks that take advantage of vulnerabilities you might not expect, which reminds us that we need to be constantly vigilant and innovative in our defenses.
Unconventional attacks.
hmm
That sounds interesting. What kind of unexpected vulnerabilities are we talking about?
We'll take these two papers, for example. A portable and stealthy inaudible voice attack based on acoustic metamaterials, and stealthy voice eavesdropping with acoustic metamaterials, unraveling a new privacy threat. These papers show how attackers are using something called acoustic metamaterials to launch inaudible voice attacks and even eavesdrop on conversations.
Inaudible voice attacks. That's pretty freaky. Are you saying that someone could use sound waves to control my devices or listen in on my conversations without me even knowing it?
Unfortunately, that's exactly what these papers are highlighting. These attacks use the unique properties of acoustic metamaterials to create sound waves that humans can't hear, but that can be picked up by devices like voice assistants. They can even be amplified to eavesdrop on phone calls.
It sounds like something out of a spy movie,
Yeah.
but it's happening in the real world. These attacks show that we need to think outside the box when it comes to cybersecurity. It's not just about protecting our networks and devices, but also about thinking about the physical environment and the unusual ways it can be exploited.
Exactly. And they remind us that the world of cybersecurity is constantly changing, and we need to be prepared for threats we might not even be able to imagine today.
Okay, let's get back to blockchain security for a minute and look at the paper NetChain, Authenticated Blockchain Topcalf Graph Data Queries, and its application in asset management. This one tackles the challenge of efficiently searching for data on a blockchain, something that's not traditionally a strength of these systems.
Right, blockchains are really good at storing and verifying data, but doing complex searches can be slow and computationally expensive. Imagine trying to find like the top 10 most valuable assets in a huge portfolio that's managed on a blockchain. That's where NetChain comes in.
So NetChain aims to make those searches more efficient. How does it actually work? Does it change the fundamental structure of the blockchain itself?
It actually introduces this new two-layer index that makes those top K searches much faster. Think of it like a specialized index for blockchains, similar to how an index in a book helps you quickly find the information you're looking for. This means you can get the data you need without having to process the entire blockchain, which saves a lot of time and resources.
So it's not about changing the blockchain itself, but finding a smarter way to access and search the data it stores. This could be a game changer for things like asset management, supply chain tracking, and any other area where analyzing real-time data on a blockchain is really important.
Definitely. And NetChain not only makes things more efficient, it also makes sure that the search results are authentic and accurate, which is essential for maintaining trust and security in any blockchain-based system.
Now let's turn our attention to another threat that just won't go away, ransomware. The paper, Hierarchical Pattern Decryption Methodology for Ransomware Detection, using probabilistic cryptographic footprints, presents a new approach to detecting these increasingly sophisticated attacks.
Yeah, ransomware has become a global problem, causing serious damage to businesses and organizations everywhere. Traditional methods for detecting it often rely on recognizing known malware signatures, but the attackers are always coming up with new ways to avoid being detected.
So this new methodology seems to take a different approach. It's not about looking for specific signatures, but about analyzing the actual encryption patterns used by the ransomware.
Exactly. Think of it like identifying a criminal by their unique fingerprints. Every ransomware variant leaves behind these telltale signs, a kind of cryptographic footprint that can be used to detect it, even if the code itself is brand new.
They talk about using a hierarchical framework that combines clustering algorithms with machine learning to find these ransomware-induced anomalies. It sounds like a multi-layered defense system that can adapt and evolve as new ransomware threats emerge.
And that's exactly what makes this approach so promising. It's not about chasing after specific signatures, which can quickly become outdated, but about understanding the fundamental patterns of ransomware encryption and detecting anything unusual that points to malicious activity.
This research gives us some hope in the fight against ransomware. As these attacks become more sophisticated and widespread, developing effective ways to detect and prevent them is crucial for protecting our digital world.
Okay, now let's delve into this paper about backdoor attacks. Comprehensive evaluation of cloaking backdoor attacks on object detector in real world. This research focuses on a particularly sneaky type of attack that targets object detectors, which are AI models used for things like image recognition and object tracking.
So backdoor attacks are like hidden vulnerabilities that can be triggered to make an AI system do something it shouldn't, right? And in this case, the attackers are going after object detectors, which are being used more and more in critical systems like self-driving cars and security systems.
Exactly. Just imagine a self-driving car that suddenly can't recognize a stop sign because its object detector has been compromised. That's the kind of danger we're talking about with these backdoor attacks.
And this paper focuses on what they call cloaking backdoor attacks, which are designed to be stealthy and only activate under very specific conditions. That makes them incredibly hard to find. How do these attacks actually work?
Cloaking backdoor attacks use triggers that are hidden inside seemingly normal objects. For example, an attacker could inject a backdoor into an object detector that's triggered by a specific type of hat. So when the object detector sees an image of someone wearing that hat, it might misclassify the person as something harmless or even fail to see them at all.
That's really sneaky. It's like planning a secret code that only activates under certain circumstances. This research highlights how important it is to develop strong defenses against these backdoor attacks because they're so hard to detect and can have really serious consequences, especially as we use more and more AI systems in our lives.
Now let's turn our attention to large language models, or LLMs, and the security implications of this technology. The paper, PromptShield. Deployable detection for prompt injection attacks sheds light on a new type of attack that's specifically targeting these powerful AI models.
LLMs, like the one we're using right now to have this conversation, are changing the way we interact with information. They can generate human-quality text and code. But as with any new technology, there are new vulnerabilities that come with it.
Right, and prompt injection attacks exploit the way LLMs process input. By carefully crafting these prompts, attackers can manipulate the model's output and potentially make it generate harmful or misleading content. It's like tricking a helpful assistant into doing something bad.
The paper talks about PromptShield, which is a system designed to detect and prevent these attacks. It basically acts as a security checkpoint, analyzing prompts for any signs of malicious intent before they're processed by the LLM.
And as LLMs become more integrated into our daily lives, protecting them from these types of attacks becomes really important. PromptShield represents a big step forward in ensuring that LLM technology is deployed responsibly and securely.
Okay, moving on. Let's see how AI is being used to fight another type of attack jamming. The paper, a two-stage CAE-based federated learning framework for efficient jamming detection in 5G networks, digs into this important area of cybersecurity research.
Jamming attacks can disrupt wireless communications and cause all sorts of problems, especially for critical infrastructure. In a world that's becoming more and more reliant on wireless connectivity, protecting ourselves from these attacks is essential.
And this research focuses on creating a decentralized and efficient way to detect jamming attacks in 5G networks. They're using the power of federated learning and something called convolutional autoencoders, or CAEs, to create a network of these vigilant watchdogs that can spot and neutralize jamming signals.
Right. Federated learning allows multiple devices to work together to train an AI model without actually sharing their raw data, so you get better detection without sacrificing privacy. And those CAEs act like anomaly detectors. They learn to recognize normal patterns of network traffic and flag anything that deviates from that norm, which could indicate a jamming attack.
This approach seems perfectly suited for 5G networks, which are much more complex and distributed than previous generations of wireless technology. As we continue to rely more and more on wireless connectivity, developing strong and adaptive defenses against jamming attacks is going to be crucial for keeping our digital infrastructure stable and reliable.
Let's take a look at two papers that show how AI can both enhance and threaten cybersecurity. The first, Intelligent Code Embedding Framework for High-Precision Ransomware Detection via Multimodal Execution Path Analysis, presents a pretty sophisticated AI-driven approach to detecting even the most advanced ransomware.
We talked about ransomware earlier, and it's definitely a persistent and dangerous threat. It's evolving all the time, which makes it hard for traditional security tools to keep up. But this research is using AI to analyze the patterns in how code executes, looking for subtle clues that indicate malicious activity.
It's like having a digital detective carefully studying the footprints of an attack, able to spot those telltale signs of ransomware even if the specific code has never been seen before. This multimodal analysis looks at various aspects of code execution, like file access patterns and system calls, to get a complete picture of the attack and improve detection accuracy.
But then on the other hand, the paper Real Cats, a practical training ground for emerging research on cryptocurrency cybercrime detection, reminds us that the same tools used to fight cybercrime can also be used by the criminals themselves.
That's right. This paper introduces RealCats, which is a new data set specifically designed for training and testing AI models that detect cryptocurrency cybercrime. It includes real-world data from both criminals and legitimate sources, which gives researchers a valuable resource for developing and evaluating their detection algorithms.
But that also means that criminals could use this same data set to train their own AI models to learn how to avoid detection and improve their attack methods. It's a reminder that the battle for cybersecurity is a constant back and forth, with both sides using the latest technology to try to gain an advantage.
And then we have a complexity-informed approach to optimize cyber defenses, which looks at how the increasing complexity of modern cyber defenses can actually create weaknesses that attackers can exploit.
It's like building a fortress so complicated that even the people defending it can't find their way around, leaving blind spots for attackers to take advantage of.
Exactly. The researchers suggest a complexity-informed approach to cybersecurity, which means focusing on simplifying and streamlining defenses to make them more effective. They introduce a framework for measuring and managing the complexity of cyber defenses to help organizations identify and fix potential weaknesses.
This approach could be especially useful for large organizations with complex and often messy security infrastructures. It's like bringing order to chaos, creating a security system that's more manageable and resilient.
Next, let's look at a privacy model for classical and learned Bloom filters. This paper examines the privacy implications of Bloom filters, a widely used data structure.
Bloom filters are these probabilistic data structures that are used to quickly check if something is part of a set. They're used in all sorts of applications, like databases, spam filters, and even DNA sequencing.
Right, but because they're probabilistic, there are privacy concerns. The very act of querying a Bloom filter can leak information about the data it contains. This paper suggests a differential privacy-based model for both classical and learned Bloom filters to try and develop more privacy-preserving versions of this important data structure.
This research is really important in today's data-driven world, where even simple queries can reveal sensitive information. It's a reminder that we need to be thinking about data privacy at every level, from the algorithms we use to how we organize our data.
The paper, Investigating Application of Deep Neural Networks in Intrusion Detection System Design, explores the use of deep learning in intrusion detection systems, or IDS, which are a crucial part of cybersecurity.
Traditional IDS often rely on rule-based systems or signature matching to detect malicious activity. But these approaches can be brittle, and they struggle to keep up with the ever-evolving tactics of attackers. Deep learning offers a more adaptive and flexible approach, allowing IDSs to learn complex patterns and spot attacks that have never been seen before.
Right. The researchers looked into the effectiveness of deep neural networks, specifically multi-layer perceptrons, in detecting different kinds of network intrusions. While their initial findings showed some limitations, Their research highlights the potential for deep learning to really improve intrusion detection capabilities, an area that's ripe for further exploration.
Okay, let's move on to a paper that shows how AI can be used to make ransomware attacks even more effective, which is a scary reminder that the same technologies that can help us can also be used against us.
The paper, Intelligent Code Embedding Framework for High-Precision Ransomware Detection via Multimodal Execution Path Analysis, focuses on developing an AI-driven framework that can detect ransomware by analyzing the execution patterns of code.
So it's like having an AI detective that can examine the digital footprints of an attack and figure out exactly what's going on.
Yes, but the authors also point out that the same technology could potentially be used by attackers to create more sophisticated and evasive ransomware variants.
That's unsettling. Imagine a type of ransomware that's constantly adapting and learning, figuring out how to avoid detection by analyzing the very tools that are trying to catch it.
That's the potential threat we're facing with AI-powered malware. Now let's look at web execution bundles, reproducible, accurate, and archivable web measurements. This paper delves into the challenges of taking accurate measurements on the web, which is important for all sorts of tasks, from security analysis to performance optimization.
Existing tools for web measurements are often inaccurate, inconsistent, and not very reproducible, which makes it hard to draw reliable conclusions. It's like trying to study a chameleon that keeps changing its color.
Right. So the researchers have introduced WebRec, which is a new web measurement tool designed to address those challenges. WebRec is meant to be accurate, general, and comprehensive, capable of capturing all sorts of web events and behaviors with high fidelity. They've also introduced a new archival format, .web, for storing and sharing these web measurements, which will make things more reproducible and encourage collaboration among researchers.
As we continue to rely more and more on the web, having access to accurate and reproducible web measurements is going to be crucial for understanding and addressing all sorts of security and privacy concerns.
And then we have provisioning time-based subscription in NDN, a secure and efficient access control scheme which focuses on enhancing security and privacy in named data networking, or NDN, which is a future internet architecture that's all about content rather than specific locations.
NDN has the potential to improve security, scalability, and content delivery, but it also comes with its own set of challenges. This paper proposes an encryption-based access control scheme for NDN that uses time-based subscriptions. It's like subscribing to a streaming service for a limited time. This scheme makes sure that only authorized users can access the content during their subscription period.
Exactly. It's like putting a digital lock on the content that automatically unlocks and locks itself based on the user's subscription status. And the scheme also includes an anonymous and unlinkable authentication mechanism which protects user privacy and prevents denial of service attacks.
As we transition to new internet architectures, ensuring that our data stays confidential and untampered with is going to be more important than ever.
Let's move on to a paper that looks at verifiable inference in large language models, or LLMs, the paper TOP-PLOC, a locality-sensitive hashing scheme for trustless verifiable inference, introduces a new way to ensure that the computations done by LLMs are accurate and haven't been tampered with.
LLMs are being used in more and more applications where trust and transparency are really important things like content moderation and decision-making. But verifying that the computations done by LLMs are correct can be challenging because these models are so complex. Imagine trying to audit the work of a super intelligent but completely opaque AI assistant.
Right. So the researchers have proposed TOP-PLOC, which uses something called locality-sensitive hashing to create compact and verifiable representations of LLM activations. These representations act like digital fingerprints that allow users to verify that the LLM is doing its computations as expected.
This research is a big step forward in building more transparent and accountable AI systems. As LLMs become more ingrained in our lives, making sure they behave as intended is crucial for maintaining trust and preventing potential harm.
Now let's look at FDLLM, a text fingerprint detection method for LLMs in multi-language, multi-domain black box environments, which highlights the difficulties in figuring out which specific LLM is behind a given piece of text. Imagine getting a piece of text and wondering, which AI wrote this?
It's like trying to figure out who painted a picture when the artist is unknown.
Exactly. The researchers have come up with FDLLM, a new method for detecting the unique fingerprints of different LLMs in their generated text. And FDLM works even in black box environments where we don't know how the LLM works internally. It's like trying to solve a mystery with very few clues.
This research is especially relevant now that LLMs are creating all sorts of content, from news articles to social media posts, Being able to identify the source of LLM-generated text is crucial for things like figuring out authorship, detecting plagiarism, and even fighting disinformation.
Demystifying OS kernel fuzzing with a novel taxonomy provides a great overview of OS kernel fuzzing, which is a really important security testing technique.
We've talked about fuzzing before, and it's basically about throwing a bunch of random inputs at a program to see if it breaks. It's a great way to find vulnerabilities that might otherwise go unnoticed.
Right, but fuzzing the operating system kernel, the heart of a computer's operating system, is especially complex and challenging. So the researchers did a systematic study of OS kernel fuzzing, analyzing 99 academic studies and identifying 9 core functionalities that are unique to kernel fuzzing. They developed a new taxonomy for classifying different fuzzing approaches, which helps us better understand this critical area of security research.
Their work highlights the importance of ongoing research in this area because kernel vulnerabilities can have really serious consequences for system security.
Then we have cryptographic compression, which introduces Encore, a protocol that aims to combine data compression and encryption into a single efficient process. It's like packing your suitcase and locking it at the same time.
Traditionally, compression and encryption are treated as separate steps, but Encore challenges this idea by recognizing that both lossless compression and encryption involve transforming data into a more uniform distribution.
And Encore takes advantage of this similarity to do both tasks at once, potentially leading to significant efficiency gains in data storage and transmission. This could be a game changer, especially in situations where security and efficiency are both top priorities.
Evaluation of isolation design flow, IDF for single-chip cryptography as SEC application, looks at the isolation design flow that Xilinx, a big FPGA vendor, offers to make FPGAs more secure.
FPGAs, or field programmable gate arrays, are these reconfigurable chips that are used in a wide range of applications, including cryptography. They're very flexible and powerful, but they also have security challenges. Imagine a circuit board where you can rewire the connections whenever you want.
That's the beauty of FPGAs, but it also means that if one part of the chip is compromised, it could potentially affect other parts. So Xilinx's isolation design flow is meant to reduce this risk by creating isolated regions within the FPGA, preventing faults or attacks in one region from spreading to others. It's like building firewalls inside the chip itself.
The researchers tested how effective IDF is by implementing a cryptographic application using this security feature and then trying to cause faults in different parts of the chip. Their findings give us valuable insights into the strengths and weaknesses of IDF, helping developers and security engineers make informed decisions about when and how to use it.
Understanding, implementing, and supporting security assurance cases in safety-critical domains explores the challenges and opportunities of using security assurance cases, or SACs, in systems where safety is critical.
SACs are like structured arguments that provide evidence and reasoning to back up claims about the security of a system. It's like building a legal case for the security of your system, presenting evidence to support your claims. And the researchers are focusing on using SACs in areas like automotive and medical devices, where security failures can have life or death consequences.
Imagine designing a self-driving car. A SAC would basically provide a comprehensive argument for why the car's software and hardware are secure, addressing potential vulnerabilities and explaining how risks are mitigated. The paper introduces Cascade, a new approach for creating and managing SACs that aligns with industry standards and incorporates quality assurance measures.
Private minimum Hellinger distance estimation via Hellinger distance differential privacy introduces a new way to estimate statistical parameters while still protecting privacy.
We've talked about differential privacy before, and it involves adding noise to data sets to protect individual privacy. It's like blurring a photo to make it harder to identify individual faces, but you can still see the overall picture.
Right. This paper proposes a new definition of differential privacy that's based on the Hellinger distance, which is a statistical measure of how different two probability distributions are. It's like comparing the shapes of two clouds to see how much they differ.
This new definition, called Hellinger differential privacy, offers some potential advantages in terms of both privacy and accuracy. And the researchers have developed private versions of common statistical estimation algorithms using this new definition, showing that it's possible to combine differential privacy with robust statistical methods.
Okay, let's move on to a paper that dives into the world of physical layer security.
Sounds good. What do we have?
Stealthy voice eavesdropping with acoustic metamaterials. Unraveling a new privacy threat uncovers a new type of attack that could compromise the privacy of our voice communications. Imagine being able to listen in on a phone call from a distance without any special equipment.
That sounds like something out of a spy movie. How is that even possible?
The researchers show that it's actually possible using acoustic metamaterials. These are engineered materials that can manipulate sound waves in ways that we don't usually see in nature. In this case, they use these materials to create a device called super ear, which can amplify the sound waves coming from a target's phone earpiece. Think of it like a device that can focus sound waves like a lens, allowing you to hear whispers from across the room.
This research really highlights the need for us to be more vigilant in protecting the physical layer of our communication systems. Even channels that we think are secure can be vulnerable to these sophisticated attacks that exploit the properties of sound waves.
Let's move on to a paper that explores the world of deep reinforcement learning, or DRL, UNIDOR, a universal framework for action-level backdoor attacks in deep reinforcement learning, exposes a new type of attack that could compromise the safety and reliability of DRL systems.
DRL is a really powerful machine learning technique that allows AI agents to learn complex behaviors through trial and error. It's like training a dog with rewards and punishments. DRL is being used more and more in various applications, from robotics to self-driving cars.
But just like any other AI system, DRL is susceptible to attacks. And in this paper, the researchers introduce UNIDOR, which is a universal framework for injecting backdoors into DRL systems. These backdoors can be triggered to manipulate the agent's actions, potentially causing it to behave in dangerous or unpredictable ways. Imagine a self-driving car that suddenly swerves into oncoming traffic because its DRL system has been compromised.
That's a scary thought. So these attacks can basically hijack the decision-making process of a DRL agent, making it do things that its creators never intended.
Exactly. As we start using DRL systems more and more in our lives, ensuring their security and integrity is crucial for preventing potential harm. This research highlights the need for developing robust defenses against these new threats and for being very careful about the potential risks before we deploy DRL systems in safety-critical applications.
We've talked about how AI can be both a benefit and a threat to cybersecurity. And this next paper really digs into that duality. It focuses on how deep learning-based intrusion detection systems are vulnerable to backdoor attacks.
The paper PCCAP Backdoor Poisoning Generator for Network Traffic in CPS IoT Environments, shows how attackers could manipulate these systems to avoid detection. Intrusion detection systems, or IDSs, are really important for protecting networks from malicious activity. They're like digital security guards that constantly monitor network traffic for any signs of intrusion. Deep learning has shown a lot of promise in improving the capabilities of IDS, allowing them to detect sophisticated and previously unknown attacks.
But like any AI system, deep learning-based IDS are vulnerable to attacks, right? The researchers in this paper introduced PCCAP backdoor, which is a technique for injecting backdoors into the datasets that are used to train these IDSs.
It's like planting a mole within the security team. These backdoors can be triggered by specific patterns in network traffic, making the IDS misclassify malicious activity as harmless. Imagine an attacker sending a seemingly harmless network packet that secretly triggers a backdoor in the IDS, allowing their attack to slip through undetected.
This research shows how important it is to be very careful about the training data used for AI-based security systems. As we rely more and more on AI-driven security, we need to anticipate and mitigate these potential vulnerabilities that attackers could exploit.
Let's move on to CENSOR, Defense Against Gradient Inversion via Orthogonal Subspace Bayesian Sampling. This paper presents a new defense against gradient inversion attacks, which can threaten the privacy of sensitive data used in federated learning.
Federated learning is a way to do machine learning, where multiple devices work together to train a model without sharing their actual data. It's like a group of scientists collaborating on a project, each contributing their expertise without revealing their raw data.
Right. And federated learning has some real privacy advantages, but it's not foolproof. Gradient inversion attacks can actually use the information exchanged during federated learning to reconstruct sensitive data from the model updates. It's like putting together a puzzle from the pieces that are left behind.
So the researchers in this paper have come up with CENSOR, which is a defense mechanism that changes those model updates to prevent gradient inversion attacks. It's like adding noise to the communication channel so the clues are scrambled.
CENSOR uses the fact that model parameters are very high-dimensional to hide sensitive information in a subspace that's orthogonal to the original gradient. It's like hiding a message in a secret code that can only be deciphered by someone with the key.
As federated learning becomes more common, especially in areas where privacy is really important, like healthcare, making sure the data stays secure and confidential is going to be essential. CENSOR seems like a promising way to mitigate gradient inversion attacks so we can enjoy the benefits of federated learning without sacrificing privacy.
The paper, A Theoretical Basis for MEV, delves into the concept of maximal extractable value, or MEV on the blockchain. MEV refers to the potential profit that can be made by manipulating the order of transactions on a blockchain.
Imagine being able to get ahead of a big trade on a decentralized exchange and profiting from the price change. That's basically what MEV is, and it raises concerns about fairness and manipulation in these decentralized systems.
The researchers in this paper have developed a theoretical framework for understanding MEV. It's a rigorous mathematical approach to analyzing its properties and implications. It's like coming up with a set of laws that govern how MEV behaves, which will help us understand it better and come up with ways to mitigate its negative effects.
As blockchains become more valuable and widely used, understanding and addressing MEV is going to be crucial for ensuring that these systems are fair and stable. This research provides a solid foundation for designing more robust and secure blockchains that minimize the potential for MEV exploitation.
Now let's shift gears and talk about a paper that challenges some long-held beliefs in the world of differential privacy. Differential privacy with higher utility by exploiting coordinate-wise disparity. Laplace mechanism can beat Gaussian in high dimensions.
We've talked about differential privacy, and it involves adding noise to data sets to protect individual privacy. And traditionally, the type of noise added is the same for all data points. It's like adding the same amount of static to every pixel in an image.
Right, but the researchers in this paper suggest a different approach, adding noise that's independent but not identically distributed. It's like adding more static to some pixels than others, depending on how sensitive they are.
So this research challenges the idea that Gaussian noise is always the best choice for achieving differential privacy in high dimensions.
And their findings open up new possibilities for designing privacy-preserving mechanisms that are more efficient and effective. As differential privacy becomes more widely used, finding ways to optimize its utility is going to be crucial for making sure it's practical and useful.
Managing large enclaves in a data center presents a new technique for migrating secure enclaves with minimal downtime. Enclaves are these secure execution environments that protect sensitive data and code from unauthorized access. They're like digital vaults for safeguarding valuable assets.
Migrating large enclaves, which can contain gigabytes of data, can be time-consuming and disruptive. Imagine trying to move a bank vault from one building to another without interrupting its operations.
It's a tough challenge for sure. The researchers introduce OptMig, a new technique that combines compiler optimizations with a new migration mechanism to reduce the downtime involved in migrating enclaves. OptMig significantly cuts down on the amount of data that needs to be transferred during migration, which results in almost zero downtime. It's like packing the contents of the bank vault more efficiently so the move is quicker and smoother.
This research is particularly relevant for cloud computing environments, where secure enclaves are becoming more and more common for protecting sensitive workloads. As we rely more on cloud services for essential operations, making sure these enclaves can be migrated seamlessly is essential for maintaining service availability and data security.
Okay, this next paper sounds really interesting. It introduces a blockchain-based system for revealing information in the future. Send message to the future. Blockchain-based time machines for decentralized reveal of locked information presents new approach to something called timed release cryptography.
Imagine sending a message that can only be opened at a specific time in the future. That's essentially what timed release cryptography is all about. The researchers have used the decentralized and tamper-proof nature of blockchains to create a system that can securely reveal information at a predetermined time.
It's like a digital time capsule that automatically opens at the appointed hour. They're combining a new timed release cryptography system with a secret sharing scheme to make this work.
Right. Secret sharing involves splitting a secret into multiple pieces, distributing them among different parties, and requiring a certain number of pieces to reconstruct the original secret. In this case, the secret is the information that needs to be revealed, and the pieces are distributed among different nodes on the blockchain. And the timed release cryptography ensures that the pieces can only be combined and the secret revealed at the specified time.
This research opens up new possibilities for applications like secure voting, escrow services, and even things like timestamped document releases. It's exciting to see how blockchain technology can be used to create these innovative solutions.
Let's move on to a paper that focuses on making watermarking techniques for AI-generated text more robust.
Okay, what's new in this area?
The paper's called Provably Robust Multi-Bit Watermarking for AI-Generated Text. It introduces a new way to embed watermarks in AI-generated text, watermarks that can withstand all sorts of manipulation.
Watermarking is like a digital fingerprint, right? It helps us know if content is authentic and where it came from. But how do you watermark text in a way that's hard to remove or mess with?
This new method uses a technique called pseudo-random segment assignment. It's like scattering puzzle pieces across the board, making it really hard to remove or rearrange them without messing up the whole picture. And the researchers have also come up with ways to make their watermarking even more robust, so it can resist those sneaky attacks that try to change or manipulate the text.
Robust watermarking is going to be crucial as we see more and more AI-generated content. This research is helping us move towards more reliable ways to authenticate and trace content in a world where it's getting tougher to tell what's human-made and what's AI-generated.
Now let's dive into a fascinating and maybe slightly unsettling area where neurotechnology and security intersect. The paper, A Mathematical Framework for the Problem of Security for Cognition in Neurotechnology, looks at the potential risks and challenges of securing our very thoughts.
Neurotechnology covers things like brain-computer interfaces, neuromodulation devices, and other technologies that directly interact with the brain. These technologies have amazing potential for treating medical conditions, enhancing cognitive abilities, and improving how humans and computers interact.
But they also bring up some serious ethical and security concerns. Imagine a world where someone could access or manipulate your thoughts and emotions. That's the kind of dystopian scenario this paper is addressing.
It's a stark reminder that as we develop these powerful technologies, we need to think about the risks involved and create safeguards to protect ourselves from potential misuse. This research provides a framework for analyzing the security of our cognitive processes in the context of neurotechnology, which is crucial for ensuring that these tools are developed responsibly and ethically.
Let's shift our attention to the robustness of local differential privacy, or LDP protocols. The paper on the robustness of LDP protocols for numerical attributes under data poisoning attacks looks at how vulnerable these protocols are to malicious manipulation.
LDP is a technique for protecting individual privacy in datasets by adding noise to the data before it's shared or analyzed. It's like blurring a photo to protect people's identities while still preserving the overall image.
But LDP protocols aren't perfect. This research looks at how robust various LDP protocols are to data poisoning attacks, where attackers try to inject fake data into the dataset to skew the results. They identify factors that make a protocol more or less vulnerable to these attacks, giving us insights into how to design more robust LDP protocols that can withstand malicious manipulation.
This research is so important as we try to find that balance between using data effectively and protecting privacy. It shows that we need to be constantly vigilant and innovative in developing privacy-enhancing technologies that can stand up to these sophisticated attacks.
This next paper tackles those poisoning attacks in federated learning and differential privacy from a system-level perspective. Poisoning prevention in federated learning and differential privacy via stateful proofs of execution presents a way to ensure the integrity of data and computations in these distributed settings.
We've talked about how both federated learning and differential privacy can be vulnerable to poisoning attacks, where bad actors inject fake data to mess with the results. This paper takes a different approach to preventing these attacks, using something called stateful proofs of execution, or POSX.
POSX leverages those hardware security features to create verifiable proofs that show the data and computations performed on a device are authentic and haven't been tampered with. The researchers actually implemented this approach in a system they call SLAPP, and they showed that it can effectively prevent poisoning attacks in real-world scenarios.
It's really interesting to see how hardware security features can be used to make software systems more trustworthy. As we become more reliant on distributed and collaborative computing models, ensuring the integrity of data and computations is absolutely critical.
Now let's explore this interesting area where large language models meet deep reinforcement learning. The paper, When LLM Meets DRL, Advancing Jailbreaking Efficiency via DRL-Guided Search, introduces a new technique for jailbreaking LLMs using DRL.
We've discussed LLMs, and their potential for misuse before jailbreaking is basically bypassing safety restrictions and getting the model to generate content that could be harmful.
The researchers have developed something called RL Breaker, a system that uses DRL to efficiently search for prompts that can jailbreak LLMs. RL Breaker treats this whole jailbreaking process as a search problem, using a DRL agent to guide the search and find those effective prompts.
And they showed that RL Breaker is effective at bypassing safety measures and generating harmful content on a variety of LLMs. This just goes to show how challenging it is to ensure that LLMs are safe and aligned with our values, especially as these models become more powerful and more readily available.
Okay, next up we have fuzzing at scale, the untold story of the scheduler. This paper looks at the challenges and opportunities of fuzzing many programs at the same time.
Fuzzing, as we've discussed, is all about uncovering software vulnerabilities by basically throwing random inputs at programs and seeing if they break. This research dives into the role of the scheduler in those large-scale fuzzing operations. The scheduler is what decides which programs to fuzz and for how long.
And the researchers show that dynamic schedulers, which adjust the fuzzing time allocation based on how each program is progressing, can significantly outperform those simpler schedulers. Their work highlights the importance of optimizing that fuzzing process to find as many vulnerabilities as possible within the time and resources you have.
So efficiency is key when you're fuzzing at scale. As software projects become more and more complex, optimizing this process is crucial for ensuring security.
Physical layer deception with non-orthogonal multiplexing presents a new approach to physical layer security that's all about deceiving eavesdroppers.
Physical layer security uses the inherent characteristics of the communication channel itself to protect transmissions. And this paper introduces physical layer deception, or PLD, which combines physical layer security with deception techniques.
PLD transmits both real and fake messages at the same time using something called non-orthogonal multiplexing. It's like having multiple conversations happening on the same radio frequency, making it tough to separate them. Those deceptive messages are meant to confuse eavesdroppers, making it harder for them to understand what's going on.
So it's like a proactive defense mechanism for wireless communication. By actively trying to mislead adversaries, PLD makes wireless networks more secure and resilient. It's a great example of how deception can be a really effective tool in cybersecurity.
The revised boomerang connectivity tables and their connection to the difference distribution table takes us into the mathematical world of boomerang attacks, which are a cryptanalytic technique used to break cryptographic algorithms. This paper looks at the relationship between these tables and what they mean for cryptographic security.
Boomerang attacks exploit the differential properties of cryptographic algorithms. These properties basically describe how changes to the input affect the output. And the researchers in this paper have introduced something called revised boomerang connectivity tables, providing a more detailed analysis of those differential properties.
They also link these tables to the difference distribution table, which is a fundamental tool in cryptanalysis. Their work provides valuable insights for designing more secure cryptographic algorithms that can resist boomerang attacks.
Cryptography is the foundation of security in our digital world, so understanding and mitigating advanced cryptanalytic techniques like boomerang attacks is essential for keeping sensitive information safe.
Let's move on to from ad identifiers to global privacy control, the status quo and future of opting out of ad tracking on Android. This paper looks at how well different opt-out mechanisms actually work for preventing ad tracking on Android devices.
Right, ad tracking lets advertisers collect data about users' browsing habits and then target them with personalized ads. And Android users have options to opt out of this tracking, like using the Android A guide setting or the Global Privacy Control (GPC) signal.
The researchers found that neither the ADI setting nor GPC consistently prevents ad tracking by apps. Their analysis of network traffic from various Android apps showed that many apps continue to collect and share user data even when users have opted out.
This highlights the challenges we face when it comes to protecting privacy choices in this complex world of digital advertising. As people become more aware of and concerned about their privacy, we need to develop more robust mechanisms that give them control over how their data is collected and used.
And finally, let's wrap up with a paper that introduces a general framework for auditing how data is used to train machine learning models. A general framework for data use auditing of ML models presents a technique for verifying whether a specific data set was used in the training process without needing access to the model's internal workings.
Data use auditing is becoming increasingly important as we see more and more machine learning models being trained on massive data sets, often collected from the web without people's consent. Imagine finding out that your personal photos were used to train a facial recognition system without your knowledge.
This framework uses black box membership inference methods and sequential hypothesis testing. Those black box methods can figure out if a specific data point was used to train a model without knowing anything about how the model works internally. And sequential hypothesis testing uses rigorous statistical analysis to figure out how likely it is that a particular dataset was used in the training process.
This research is a valuable tool for data owners and regulators who want to make sure the data is used responsibly and ethically in the development of machine learning models. As machine learning becomes more and more pervasive, data use auditing will play a crucial role in protecting privacy and promoting transparency in the development of AI.
And that brings us to the end of our deep dive into the latest cybersecurity innovations. We've explored a wide range of cutting-edge research, from blockchain security to AI-driven defenses, getting a glimpse of both the promises and the challenges that come with our increasingly digital world.
What's clear is that the world of cybersecurity is constantly changing. It takes a lot of creativity and vigilance to stay ahead of these emerging threats. And all the research we've discussed today highlights just how important it is to keep innovating, collaborating, and understanding both the technical and human sides of security.
As we navigate this complex landscape, it's important to remember that cybersecurity is an ongoing journey. We need to keep learning, adapting, and evolving right alongside the technologies that shape our lives.
Thanks for joining us on this deep dive into the fascinating world of cybersecurity. Until next time, stay curious, stay informed, and stay secure.